First, in the circuit diagram, the wires are connected to the battery. The wires are then also connected to the motor, which causes the motor to spin. When the motor spins, it causes the fan to spin, which causes linear acceleration in the marble.
The battery is connected to the solenoid. When there is current going through the solenoid stays back. When that current is broken by the switch, the solenoid pushes the marble, and the fans push the marble down the ramp. The marble undergoes circular motion when it goes through the loop and out the ramp.
First, we add the sum of forces in the x direction on the marble. This is the force of thrust by the fans minus the force of friction by the cardboard on the marble, where the force of thrust is greater than the force of friction on the marble because the marble is moving forward when the thrust is applied by the fans on the marble. We know that work is equal to force times distance times cosine theta. We then plug our sum of forces in the x direction on the marble into our force for the work equation. And we know cosine theta is equal to 1 because the marble is moving across a horizontal surface. We know that the change in kinetic energy is equal to the work done, so we set the change in kinetic energy equal to our work equation. We then plug in our variables for the change in kinetic energy equation for our work equation. We know that the initial velocity of the marble is 0 because it is at rest, so we can cancel out that part of the equation and simplify our equation. Finally, by rearranging our variables, we solve for the final velocity, which is the square root of 2 times the sum of forces in the x direction times the distance over the mass of the marble.